Welcome to P&ID Basics. My name is Dylan, and this video is part of my preparation for the PE exam, which is honestly one of the hardest exams in engineering. And as I study, I'm documenting what I'm learning so that maybe you can learn something too. If P&IDs feel intimidating or overwhelming right now, that's totally normal. My goal here is to break them down in a way that actually makes sense. Before we jump into the basics, I want to show you just how complicated P&IDs can get. Engineers use drawings like this every single day, and eventually you'll be working with systems that look just as confusing as this one. But here's the important part I want you to remember. By the end of this video, you're going to look at this same drawing and recognize way more than you think. So even though it looks scary right now, trust me, we're going to get through it. Now, this is the P&ID we're going to focus on today. At first glance, it still looks complicated, but it's actually pretty manageable. There are two inputs, two outputs, and everything revolves around this central piece of equipment, a hot water storage vessel. We're going to break down how material enters this vessel, how it leaves, and how we measure and control what's happening inside. The first thing I always do when I look at a P&ID is try to tell a story with it. These drawings aren't meant to show exact pipe lengths or dimensions. They're meant to help engineers, operators, and technicians understand how this system works. So instead of memorizing symbols right away, I like to figure out the beginning, middle, and end of the process. To help us better understand this, I've highlighted the inputs and outputs of the system. On the left side, we have the inputs. We have hot water, and we also have nitrogen. On the right side, we have the outputs, a vent, and a line going to users. Once you identify inputs and outputs, the entire P&ID starts to make a lot more sense. Here's how I interpret the story of this system. Hot water is coming in from another process, likely something very hot, possibly even producing steam. Nitrogen is also being added to the vessel. I'm making an assumption here, but I'm imagining that nitrogen is being used to help control conditions inside the tank, possibly cooling or controlling pressure. In my head, the hot water enters, conditions inside the vessel are controlled, and once that water reaches the temperature we want, it's sent out to users. At the same time, gases can build up inside this vessel, so we need a way to safely vent pressure when needed. And that's where this vent comes in. So in simple terms, material comes in, conditions are controlled, useful product goes out, and excess pressure is safely removed. Let's talk about valves, starting with these blue ones. These are normally controlled valves. You can tell by the NC as well as the filled in symbol. That means if something fails, these valves default to closed. That's important for safety. If power control is lost, we want to know exactly what these valves do. In this case, they close and flow automatically stops. Next are these orange valves. Notice two things. They're not filled in, and they have this dome-shaped symbol on the top. I personally think it looks like a little umbrella. That symbol tells us that these valves are actuated. Instead of being simply open or closed, these valves can modulate, maybe in 25% increments or something random, like maybe we want the valve to open 33%. This gives us precise control over everything. The line connected to these has two diagonal slashes. That symbol tells us that these valves are pneumatically controlled, meaning they use pressurized air to open and close. As soon as I see that line, I know this valve is part of an automated control loop that we're going to talk a little bit more specific later. But firstly, I want to talk about this valve right here. This is one of the most important components in the entire system because it deals with safety. This is the pressure relief valve. It's a purely mechanical safety device where if pressure inside the vessel ever gets dangerously high, this valve will open automatically. Even if every control system fails, this valve protects the equipment and most importantly, the people who operate it. Now let's talk about these bubbles that are all over the drawing. I've grouped them by color, blue for temperature, orange for pressure, and purple for level. You can also see they're grouped by numbers. Pressure is 101, temperature is 102, and level is 100. The tags in these bubbles follow ISA standards, which means the first letter tells you what's being measured. T for temperature, P for pressure, L for level. These ones are fairly commonplace, but some of them do get a little bit wonky. So I recommend if it's ever your first time looking at a P&ID, or if you're just not sure, look up the ISA standard and you can tell exactly what it is measuring. Now you've probably noticed that there's also more than one letter. You have second and even third letters. These tell you exactly what that device does and what it is. For example, when we see a TT, We know that the first letter means temperature, but this second letter actually tells us that this is a transmitter. So this is transmitting temperature data further on down the line into maybe what we see right here, a TIC, which is a temperature indicating controller. This will take the temperature data from the transmitter and be able to do something further on down the system. Let's go into a specific system. Level is one of the easiest systems to understand in my opinion. The level gauge right here gives operators a visual indication directly on the vessels. You can walk by and see the level instantly. The level transmitter sends that same information back to the control room so operators can monitor it remotely. Here it goes to a level indicator, and this could then be connected to a control room. Next, we'll talk about the temperature control loop. The temperature transmitter is measuring the temperature inside the vessel. That signal is sent to a temperature indicating controller, which turns the heat pad on and off as needed. If the temperature drops below a set point, for example, the heater would turn on. If it gets too hot, it would turn off. Simple feedback control. Now let's talk about this pressure system. It's a little bit more complex. The pressure indicating controller is the brain of this loop. It decides whether to add nitrogen or vent gas based on the vessel pressure. Earlier, we talked about these valves being pneumatically controlled, which means pressurized air. But our controller has this dotted line, which stands for an electric signal. So how do we get an electric signal to operate a air-powered valve? Well, that's where these PYs come in. These are I to P transducers. They convert an electrical signal into pressurized air so the valve can respond properly. The pressure transmitter on the vessel sends real-time pressure data back to the controller. That feedback allows the controller to decide whether to open the nitrogen valve, open the vent valve, or do nothing. So overall, the pressure controller balances inputs and outputs to keep the vessel in a safe operating range. It's constantly adjusting both valves to maintain stability. Now that was a lot, but we just walked through an entire P&ID from start to finish. You now understand the story, the equipment, the valves, and the control loops on this drawing. So let's take a look back at that complicated P&ID from the beginning. You might not know everything on it yet, but you're already recognizing tanks, valves, instruments, and control loops, and that's huge. There's still obviously a lot more to cover. Looking at this, you might not know what the pumps, motors, different signal lines, and advanced symbols are, but this was the foundation. If you want to keep learning about P&IDs and other I&C concepts, as well as just follow along as I study for the PE exam, make sure to subscribe. If you want more behind the scenes content about life as an early career engineer, as well as maybe just to get to know me a little bit more personally, make sure you follow me on Instagram. And remember, most importantly, love life, love yourself, and never forget, my friend, you are a genius.